Welcome back, everybody. Sorry for the delay. We'll go ahead and get straight into it. Um, just doing a quick recap. So the to get us ready for today. So as a reminder, the standard form of a circle is the x minus h times squared, that is, times y minus k squared equals the radius squared, where h comma k is the center, r is the radius. So when you're trying to find the center and the radius, make sure it's in the proper format so that it should be a minus there. So if it's not, double negative to put it into the right format. Now, the reason why we spent a long time at the very beginning talking about completing the square, because it's quite a difficult process at first. But as I said, this is not going to go away. If you remember, we're going to talk about it soon enough in Unit 2. But if you remember polynomial division, long division, if you haven't seen that, no big deal. We're gonna go over it. Every student wants to believe that, oh, I'll just have to learn it today, and then I'll like this is going to be one of those things that never comes back. No, sadly, long division comes up over and over and over again. Yes.
But
Yeah.
I tried to do some of the homework yesterday,
Uh-huh.
and we got into there was like one problem that had like four different, it was like a four polynomial,
A degree 4 polynomial. Okay.
and it was like it was just really confusing. I literally like,
Oh, it had a degree 4?
yeah.
Interesting. Do you have it written down? So okay, absolutely. If that happens, I'm gonna see that during the break, and if it shows up, we can go over that one because I think I know what to do in that situation.
That's not a common.
No. If it's a degree 4, I think what they're trying to do is make you see quadratics in disguise, is what I like to call them. But at the end of the day, on an exam or a quiz or anything like that, it should only be squares. It should only be x squareds and y squareds and stuff.
Okay, it is to the second degree, but there's four terms.
It's 4
X
terms.
squared plus 2y plus y squared minus 8 equals 0.
Okay.
We can do it later.
Yes, absolutely. No, valid point. Thank you for bringing that to my attention. So, just as a reminder about why this process is the way it is, the key thing to remember is b divided by 2 quantities squared and add and subtract. If you can remember those two facts, it kind of falls out quite naturally. And we explained it last time, but I'm still going to do it because I still think it's valid to know why things work. It's my favorite thing about mathematics is that everything has a reason. So I thought about it a lot after, and I didn't like the fact that we had two different names for these things. So if you have x squared plus, let's say, 10x, so you don't need to write this down, minus 7. Now we know that x minus a quantity squared is equal to x squared minus 2ax plus b, or plus a squared. So if I were to line that up, plus, I guess I should do plus. It doesn't change too much, but because a could be positive or negative, but either way. Da, 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 da. And this thing is glitching out, so I'm gonna have to shut it down and restart it. Go back to that page. Okay. So the reason why you make b equal you calculate b over 2 squared is that, remember, this is the same value here. This is the same number. This is a, this is just a squared. So I want my a value, or in typically, I want my b value to be this thing. So I want 10x or 10 to equal 2a. That's the only way these two things could line up. So that's why I guess I used a and is b, but in fact, let me just erase it again. Make it look better. B squared. So 2b. No, that's not how I wanted to write. Ugh. Oh, that's what it is. That's what it is. Okay. So whatever this number is, let's make it a green box. So you want it to line up. So that is to say that green box has to equal b over 2. So 2b. So if we want to know what that value is going to be, we just have to take the green box and divide it by 2. That's the reason why it's going to be b divided by 2. And then we're going to have to square it to get that term, because the -7 is almost never going to make it a perfect square trinomial. Like the chances of that happening are astronomical. Not astronomical, that's way too big of a word. Like probably 999 times out of 1,000. That it will never be that. So we have to then cleverly add 0 to get it to be in the right format. But I digress. The process is as follows. Let me delete this page now. So the only difference between case 1 and case 2 is that case 2 is where your leading coefficient is not 1. In which case, what you do, it's just a clever trick. You say, well, I know how to do it for case 1, so why not just factor out the a term from the first two things and then complete the square on the inside? And that's how we do it. The added step that makes things a little bit difficult that we were discussing is then you have to distribute. And remember, this 3 can't go inside the parentheses because it's not being raised to the second power. So now with that in mind, we're going to go to this one. So the standard form. So hopefully you guys did this, but we're going to go over it ourselves. X squared plus y squared minus 12x plus 2y plus 28 is equal to 0. So that's the general form. And so just to make it look a little bit better to me, I'm going to group the x terms together because I'm going to have to complete the square on the x's, and I'm going to have to complete the squares on the y's too. Because I want to get x minus h quantity squared and y minus k quantity squared. So I'm going to regroup it. X squared minus 12x plus y squared plus 2y plus 28 is equal to 0. And it's okay if it bleeds over a little bit into the next one. We can just write, like, that's why I gave us so much space on this one, so we can write our answer down at the very bottom for the standard form, because we're going to have to add and subtract several terms. So when we complete the square on the x terms, take half the b term. So b divided by 2 quantity squared would be, half of it would be -6 squared. So I'm going to write that down, -6 squared, which is going to equal 36. And then over here for the b term of the y value, that's 2. So b over 2 quantity squared here would be 2 over 2, which is 1 squared, which is just 1. Any questions so far? What we're doing is we're setting up completing the squares. And since the leading coefficients are 1, we're just in case 1. We don't need to do any factoring. So now we're going to cleverly add 0 twice. We're going to do it for the x's and do it for the y's. So it'll be x squared minus 12x, add 36, and then immediately subtract it so that we don't actually change anything. Then continue. So we've got the plus y squared, the plus 2y, and then we'll add 1 and subtract 1. And then we've got that plus 28 and it equals 0. And as a reminder, once again, if you like the way the book does it, it is fine, but it is less generalized. So it will only really work for conic sections. We're only going over the conic section of a circle, but in Math 127, you will go over the conic sections of the hyperbola, the parabola, and the ellipse. But we'll get there. Well, we won't get there, but 127. So the whole point of this is that now the first 3 terms of each set of x and y form a perfect square trinomial. This set right here is, and remember, this is that key little nifty trick, because it'll always form a perfect square trinomial, and you can factor it by whatever means, but it doesn't need to be done, because it always ends up being b over 2. So in this case, with the x's, the b over 2 was -6. So it should be x minus 6 quantity squared. And then y plus 2y plus 1, that's going to be y plus 1 quantity squared. And then we've got -36 minus 1, that's -37, plus 28, that should be 9, right? Should be 9. So we have x minus 6 quantity squared plus y plus 1 quantity squared minus 9 is equal to 0. Because -36 minus 1, that's -37. Add 28 is -9. But that's not in standard form, but that's very, very, very close. All we need to do is add the 9 to both sides to get it to be in the right format, which is x minus 6 quantity squared plus y plus 1 quantity squared is equal to 9. Whew. A lot of work. But my favorite thing about this is it's testing so much of your algebra skills. It's a really, really good practice of algebra because it teaches, like, it reminds us about adding 0, cleverly adding 0. It reminds us about how to factor and things like that. And it reminds us how to do some extra calculations and do some arithmetic with combining stuff. So take a sec, unless there's any questions. I'll wait for a second. I think people are still writing. Yes, JT.
How
Yeah.
come, like at the end, we need to move the 9 over?
So in order to be in quote unquote standard form, it has to have the number on the right hand side. But I mean, like, if this was on an exam, I wouldn't lose it too much. I wouldn't lose my cool when grading it. The right hand side. So like because then you can see it as r squared in the formula. So
Oh, that's right, okay.
yes.
I'll jump onto it.
Yeah. But no such thing as a dumb question. Not in this class. Not in this class. The last thing is we need to find the center and the radius. So don't say it out loud. Let everyone get a chance to think about it. Just remember, it's I'm going to write it down here, but you don't have to. It's a good practice for memorization. It's x minus h quantity squared plus y minus k quantity squared is equal to r squared. So where is the center? So it's a -6. And unfortunately, close but not correct. 6, -1, because remember, it's x minus h. So the x minus 6 is already in the right format, but the y is not in the right format because it's not y minus. So we just do the thing where we make this into y minus -1 to get into the right format. So the center should be 6, -1. And the radius squared is 9, which means that the actual radius is 3. And then we can graph it. Might as well. We haven't graphed one in a while. So plot the center. So that's going to be 6, -1. So over 6, down 1 to right there. And we'll plot that point. And then what we do is we reach out in all the 4 spokes, the north, south, east, and west, because those ones are on grid lines, so we can actually count 3. We'll do that. 1, 2, 3 to there. 1, 2, 3 to there. 1, 2, 3 to there. And then last but not least, 1, 2, 3 to there. And we'll plot those 4 points. Actually, I'm going to do them in black so it becomes, I don't know. Then we connect the circle, and it doesn't need to be perfect. It does not need to be perfect. Don't worry if it's not a perfect circle. It's not even that good of a band. No, I'm kidding. I haven't even really listened to a perfect circle, so I don't know. Okay. Any questions on that? All right, now we get into some interesting cases, things that I think are very, very fun. And I want us to really think about them, these last two problems here. So find the equation of a circle in standard form with a center at 3, 5 and contains the point -2, 2. So whenever I'm tasked with a problem that I'm not sure how to go about, first and foremost, I make sure that I realize that it's not a Canadian goose, or that it is a Canadian goose. What the hell does that mean? So have you guys seen Canadian geese in a while, like recently? You know about like so thing is my wife, when we moved to Ohio, there's a lot of them. And my wife was terrified of them because I don't know if you've ever seen them. They're very, very territorial and they'll come up to you and hiss and bite you and stuff. But she didn't know the trick about them. It's that they're just puffing out their chest. They're just trying to scare you away. So if you like buff out your chest and say what, they will run away 100% of the time. Try next time you're next to a Canadian geese, they will sprint away 100% guarantee. So the point is, it's trying to look scary, but it's not actually. Especially if you remember the key thing with mathematics is if you're stumped on a problem, try and write down the things that you know. So it says find the equation of a circle in standard form. So we know that the equation of a circle in standard form is x minus h quantity squared plus y minus k quantity squared equals r squared, where h comma k is the center. Do I have the center? Yes, I have the center. The center is 3, 5, which means that h is equal to 3 and k is equal to 5. The graph here is just for reference if you needed to use it to figure some things out. So x and y are the variables in question. So those things we can't find the specific value. But h and k, now we know what they are. The only thing we're missing, we're only missing r. If we can find r, then we have everything. We have the equation of the circle in standard form. But I don't have it yet. So, and this is like up until graduate mathematics, whenever you see a problem on an exam, there's got to be a solution, right? That's the good thing to keep in mind. Once you get into graduate mathematics, then the question kind of stems to be, does the question have an answer? Does it actually have a solution? And that's a much harder question to ask, but that's for the mathematicians. For now, we're looking at this and saying, well, there must be a way to solve this. Is there anything I could do to find R? You could graph it. And so that would be a good idea to start. So the center is at 3, 5, right there. And then a point on it is -2, +2, right there. So if I were to graph it, it would look roughly like that. I'm not so certain where exactly it'll be, but it's roughly around there. Roughly. But then oh, yes, go ahead.
I was just gonna.
Yeah, what would it be?
Well, we can count from where the point is the center down to the bottom and like Pythagorean, you know?
So love the idea, and it's a great idea. But the problem is, this is a sketch because we're not like we're trying to figure it out, but that sketch is deceiving because we don't necessarily know. The circle could be that big, but it could be that big, which would change the distance altogether. But I just said the word that kind of tells us what we should do. What is the radius? The radius of a circle, by definition, is the distance from the center to any point on the circle. So if we can find this distance, then we will have our answer. and we know something to calculate distance. So I love JT's idea at first. We could plot the point, but then we see that it's not on the same level. So there's no way to calculate exactly the number of grid lines that it crosses. And I love the idea of trying to count downwards, but unfortunately, we don't necessarily know exactly how big the circle is, so we cannot be certain where it stops. Any questions so far? We can use the distance formula to find r. So we have 3 comma 5. That'll be our x sub 1, y sub 1. And we have negative 2 comma 2. That'll be our x sub 2, y sub 2. So if you don't remember what the distance formula is, I'm going to write it down because it's good practice to just memorize to write something down. So d, the distance, which in this case will be r, is the square root of x sub 2 minus x sub 1 quantity squared plus the quantity y sub 2 minus y sub 1 squared. So we'll plug that into the formula. We get the square root of x sub 2. So negative 2 minus 3 quantity squared plus 2 minus 5 quantity squared, which is going to equal the square root of negative 5, which is negative 5 squared, which is positive 25, plus negative 3 squared, which is 9. So we get 25 plus 9, that's 34, right? Just in case. Because I want it to be 36, but no, it's 34. I want it to be 36 because then it'll be a perfect square, but it's not. Sometimes life is like that. That's the radius. So we have everything we need. Therefore, the equation of the circle is x minus h quantity squared, so x minus 3 quantity squared, plus y minus k, so y minus 5 quantity squared, is equal to the square root of square root 34. So it's going to be equal to 34. And the reason for that, I'll write that down. R squared is equal to the square root of 34 quantity squared, and the square root and the square cancel. Because the formula is x minus h quantity squared plus y minus k quantity squared equals r squared. It's not equal to r, it's equal to r squared. Any questions on that? Yes, JT.
So if it was like, if your original answer would have been 34, not the square root of 34, you would have put 34 squared.
Yes, I would like. So if D had turned out to be 34 instead, if it had been, so what I'm gonna do is if this had been gone, then this would be 34 squared, or and whatever that number is. Let's see here, 1,156. So, all right. Next one, find the equation of a circle in standard form with endpoints of a diameter at negative 4 comma 4 and 0 comma negative 2. Think about it for a second. How would you approach it? Take a second to think about it. Same situation, right? When you're tasked with something you don't know, ask yourself, what are you trying to find? I'm trying to find the equation of a circle in standard form. So I need to fit it into that format of x minus h quantity squared plus y minus k quantity squared equals r squared. But I don't have the center, and I don't have the radius. So what am I to do? The distance formula is going to be needed, and there's actually going to be something else too. So what I would recommend, if you're stumped, graph it. And maybe something good will come from looking at that. So negative 4 comma 4, that's the point right there. And 0 comma -2 is right there. So I'm going to draw this for reference. And just like before, I don't necessarily know if that's the correct circle. It's a sketch. So I can't approximate it. But what I can do is realize that's a diameter, right? And a diameter goes straight through the center. How would I be able to find it? There must be some way. Do we know any formulas? Do we know anything that would be able to do that for us? To find halfway between the x values and halfway between the y values. Learned it in unit 1.1. That's why we actually went over 1.1 first. There are two main formulas we learned. The distance formula. And what was the other one? The midpoint. The midpoint formula could it's the midpoint. So center equals the midpoint. And so we'll call this x sub 1, y sub 1, and x sub 2, y sub 2. But remember, it does not matter which one you do which. You could flip it, flop it, whatever you want to do. It will always give you the same answer. Yes.
You just do the distance formula and then divide the answer by 2, though?
So, excellent point. So JT says, can we use the distance formula? And the distance formula will be used to find the radius. But at the same time, the problem is, if this was on a grid line, then yes. Then we could count that number of distances and go to it. But the sad fact is it's not on a grid line, so we can't do that. But that is going to be used to find the radius. So center is at the midpoint. So that's going to be, and if you don't remember that formula, it's x sub 1 plus x sub 2 divided by 2, and y sub 1 plus y sub 2 divided by 2. It's the average of the x coordinates and the average of the y coordinates. That's what a midpoint would be. Yeah. So in this case, that'll be -4 plus 0 divided by 2, comma 4 plus -2 divided by 2, which ends up being -2 divided by 2. That's -1, comma 2 divided by 2, 1. Wow, I graphed that pretty damn well. That is like right on negative. Oh, no, it's not. No, I was off by a little bit. Darn. Oh, it's because my line isn't perfect, but oh well, not a big deal. That's my h comma k. We found our h, we found our k. The only thing left in the circle is to find the radius. And there are now two ways. So you could either find the radius first, or you could find the midpoint first, the center first. If you found the radius first, what I would have done is I'd find the diameter and then divide it by 2, because the diameter is double the radius. But now that we found the center, we can also use that as our secondary point. It doesn't matter which one you choose, they're going to give you the same answer, I guarantee it. So since radius equals diameter divided by 2, we'll calculate distance of diameter and divide by 2. Yes, Mark. Where did I get -4 from? Oh, you're right. No, you're absolutely right. I didn't, I made a mistake. I was looking at this one. It should be -2. So I did do it right. I did do it right. -4 plus 0 is not -2. I'm just going a little bit crazy. Aren't we all? Thank you for catching that. Thank you. Any questions on that? Thank you for catching it. So we can either use the center and one of the points, it doesn't matter which. I guarantee you both points. If you're really bored this weekend, calculate it in the 3 different ways. Calculate it by dividing the radius by the diameter by 2, calculate it by doing the distance between the center and the first point, or calculate the distance between the second point and the center. Either one of them will always be the same. Either way, so D is equal to the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. You do not need to write that, but it is not bad to practice just getting free memorization. So that'll be the square root of x sub 2, which was 0 minus -4, so that's plus 4 quantity squared. Make sure you understand that. I'll let you get to that point, and then we'll move forward. Remember, it's the square root of x squared, x sub 2 minus x sub 1. So that's 0 minus -4, but subtracting a negative is the same thing as adding it. If you take away a debt, really you're getting a net gain. Like if you have an external charge on your credit card that wasn't you, if I take it away, that money goes back into your bank account. You get $4 back. Plus y sub 2 is -2 minus y sub 1, which is -4 quantity squared. That's going to equal the square root of 16 plus 36, the square root of 52. All right. So that's the diameter, which implies that the radius r is equal to the square root of 52 divided by 2. It looks like 32 is supposed to be 52. Any questions on that? Yes, Jason.
So will we leave it as the, or 202, or will we put it into our calculator?
So, great question. So that's the radius. And if you like, I think I've said in this class, but if not, just as a reminder, in my opinion, never simplify unless you're going unless it's the end. Try not to simplify early. Try and leave it until the end. And usually it's don't simplify unless you have to. But either way, you can do it in a myriad of ways. We could find out the square root of 52 is 4 times 13. So you could factor it and you'll get square root 13 for the radius. But either way, we know the formula will be x minus h quantity squared. So it's going to be x minus -2 quantity squared plus y minus k. So y minus 1 quantity squared is equal to r squared. So that's going to be the square root of 52 divided by 2 squared. Your calculator is your best friend. Your calculator can do this for you, but if you'd like to see the algebra, I'm going to show it. So this will be the square root of 52 quantity squared over 2 squared. Remember, that's one of the properties of exponents, is that if you have a quotient raised to a power, each part gets raised to that power. You can distribute the exponent between the two of them, as long as it's only division. And so the square root and the square will cancel. You'll get 52 divided by 4, because 2 squared is 4, and that should be 13. But I guarantee you, if you plug it into your calculator, let the calculator do the work for you there. You don't need to spend too much time on basic calculations. So, final answer, x plus 2 quantity squared plus y minus 1 quantity squared is equal to 13. And then if we want to, we can check our work. Wait. Yeah. So the radius is the square root of 13, and the square root of 13 is approximately 3.6. And since I graphed this pretty dang well, let's see if it's roughly 3.6 out from here. 1, 2, 3, and about half. We did it right. Excellent. We're not 100% certain because it was a sketch, but it's a good checking tool. If we're close enough, we're probably right. Challenging, like fun problem, in my opinion. I think it's a cute problem, like just thinking about all the different things that need to go into it. That's the reason why we introduced this section now, is that now that we have the distance formula and the midpoint formula, we can find the center and the radius by using those two formulas. Okay? Time, we're good. I think it would behoove us to do another example like this, where I give you it in general form and we convert it to standard form, just because that's a lot of algebra and it's good practice. So I'm going to add one extra page here. You can add this to the back or whatever. We're going to do one more. So bonus example. Just make sure it's a fun problem. Find the center and radius of x squared. All right. And we're going to make this one have a fraction, by the way, just so we're comfortable with them. But remember, you got your calculator. So someone give me an odd number. 33 plus 33x. I'm going to write it in the better format. And honestly, this is the way I'm going to write it on an exam if this problem shows up. I'm going to write it like this because I think this just makes way more sense. But so x squared plus 33x plus y squared. Someone give me an even number. 22. That's exactly what I was thinking. Straight up. 22y plus someone give me a number between 50 and 100. What was it? 75. Plus 75 is equal to 0. All right. So we need to complete the squares on them. I'd like you to start working through that. I will slowly fill in details. Oh, sure. Going to be not a nice number, but we can handle it because we got calculators. Find out something just as a random little tidbit because I am quite upset with my body at the moment. So my wife is still recovering from the flu. My son is still he and I are over it, but we're getting the thing where like I was wondering, why do I feel so tired even though I'm done with the sickness, even though like it's gone for the most part? Why do I still feel tired? And so I asked ChatGPT. They gave me the information. Saying basically that the white blood cells that are normally in the rest of your body trying to make executive functions for your muscles and everything like that, they're being siphoned to kill off the remaining infection. So your body's going to be tired because it can't recover all that strength because the white blood cells are going elsewhere, not for the rest of the body. Fun little fact. Another interesting fact that you can't unknow, by the way, did you know? So hermit crabs, right? Hermit crabs. They grow just like we do, but the shell is fixed. How do they get new shells? It's a fascinating thing. Like, look it up. It's fascinating. If they find a bigger shell, if it's too big, they will sit there and wait until other hermit crabs come together. And then they will literally line up from smallest to largest and then do a little swapsy swoop. Like they'll do a little swap. Fascinating, fascinating creatures. Anyways, now you can't unknow that and you can bring that out at parties. Use your calculator. It's your best friend. I have the standard formula circle if you'd like to check your work. Make sure, like, if you were just following along, if it was still something you're struggling with, make sure you understand each step. Take a second and explain it in your own words, in your head. Why did I, like, what did I do? How did I do it? That's the thing I've learned in mathematics, especially since grad school. If you want to understand something, explain it. Try and explain it to another person, even if that person's just an imaginary person, even if that's just a wall. Explain it to them, and you will better solidify it in your head. Any questions on the standard form? And with this one, if this was really like this was supposed to be an over the top example that was going to be awful with the numbers. If you don't want to write it as a fraction and just want to write it as a decimal number, be my guest on this one. That would be obscene. This is a very, very uncomfortable example. Okay. Any questions on the standard form? Yeah. Yep. So yeah, the orange is saying what the perfect square trinomial for the x will be. The green is saying, I mean, it's hard to see that it's green, but the green is saying what the y perfect square trinomial will be. And then the brown, that kind of looks burgundy or whatever, that's combining all three of those like terms, those three constants. Negative 1089 over 4 minus 121 plus 75 ends up being negative 173, 1273 over 4. And then what I did is I added it to both sides to get it to be in the proper format. Any other questions? All right. So then where's the center? Don't say it out loud. Actually, now that I think about it, let everyone get a chance to think about it. The center should be negative 33 over 2. And then what was it, Mark? Positive 11. That's right, because the x isn't in the right format because it's not x minus h. So we have to do the double negative thing. And you can even write that above it. And then the radius. John Doe student says that the radius is 1,273 over 4. Why is John Doe student wrong? You got to take the square root. That is not the actual radius. That's the radius squared in the formula. This is r squared. Let's use blue. This right here is r squared. So r will equal the square root of 1,273 over 4, which is I mean, you can leave it like that, or we could actually take the square root of it. And write it as an approximation. I will try to make sure on the exam. Honestly, I don't feel like this is giving away something. So, I mean, this is one of the sections that's going to be on exam 1, right? It's one of the sections covered. So you can expect to see at least one circle problem there. I can't say what type of circle problem it would be, but you know there's going to be at least one. And it'll probably involve graphing it some way. All of them, we had to graph them. We didn't write it. So as a student, this is me talking as a student in your class, I'd say I probably have to graph one. And so as your teacher, what I'll tell you is, if you're not getting a nice radius, if you're not getting a whole number, it probably means you made an algebra error somewhere, okay? If you're going to have to graph it, you're going to have to graph it. So that's going to be approximately 17.84. And that is our answer. The question wasn't asking for the standard form, but we did it because we needed the standard form to find the center and the radius. Any questions on that? Yes, I'll.
I'm not understanding how it's not negative 1,272.
Sure. So what I did is I was doing this off on the side, but basically I'm gonna use the commutativity of addition, because remember, we can treat every subtraction as an addition of a negative number. I'm gonna jumble it all around so all those things, those constants are combined together. So this is gonna be negative 1,089 over 4 minus 121 plus 75, and that will equal 1,273. Sorry, negative 1,273 over 4. Is that all right? Did I mess up? So 1,089, 4. I keep getting 1,273. Is anybody else? Did anybody get my answer? No. It might have been. Try one more time. You got my answer the next time you did it? Okay.
No, I'm not giving it.
Go ahead and enter again. We're going to take a break right now. Let's come back together at 10 o'clock. And we'll start the next section. People watching the recording, go ahead and do some guided meditation. All right, and we're back into it, and we're starting up the new unit. Oh, I didn't get to see, JT, you had that question about that one problem. Was that what we were doing at the end step there? Ish. All right. I don't foresee this taking too long, so hopefully we have a little time at the end to discuss that. So one of the things that we're going to need to do before we talk, this is one of the last bits of preliminary, pre-calculus material that's needed in order to talk about the next step. So the key things we're going to be learning from this section are how to solve inequalities, and then also how to write them in interval notation. So just if we haven't seen them before, the real numbers are, and hence the number line, are what we call an ordered set. That's a very, very unique property in mathematics. Plenty of things that we study are not ordered sets, but in particular, what that means is that we can relate or order everything in the real line based on where it is on the number line. through a myriad of symbols. In particular, there are four main symbols. There is this one, which stands for less than. We have the less than symbol, but then a bar underneath it. That's less than or equal to. Then you have the opposite direction. We have the greater than. And then we have the greater than or equal to. So I have a little tick with myself. A lot of people will say that it's less than. I usually like to add the stipulation that it's strictly less than, because there's a little bit of ambiguity. If I say X is less than 4, it could mean, depending on who you're talking to, it could mean that you mean 4 or less, because they're like just in general conversation. So I usually use the term strictly, and that brings up a key point. So the ones without the bar, these two, are what we call strict inequalities. Whereas the other two, the ones that have an equal sign, are non-strict. So you'll hear me use that terminology a lot. That's the way I like to talk about them. And that will play a role in a lot of places. So understanding a strict versus a non-strict is important. Strict means it is strictly less than. It cannot be equal to. Whereas the non-strict means it could be less than, greater than, or equal to. So for example, if I have the mathematical statement, X is greater than 2, that is called an inequality. And then to write down what that would mean, and that means that X is some number greater than, strictly, that is, greater than 2. So it's a statement here. If I say X is greater than 2, that means that X is just some number that is greater than 2. X could be 7, could be 5 billion, could be 3,000, as long as it's, or 2.000000001, any of those numbers would work. And so the corresponding set, or its corresponding set, is all numbers that are greater than but not equal to 2. So its corresponding set, if you're looking for the set of all answers to that equation, that would be all the numbers that are greater than but not equal to 2. 2.01, 2.0001, 2.5, 3 billion, all those numbers are part of the set. And if you were to graph that on a number line, or I'll wait until you finish writing. If we were to write that on a number line, what it would look like is you put a dash mark here and write a 2. And then this is the old way to do it. And I hate it. And I'll explain why in just a second. But we'll put an open circle here, and then all the numbers greater than it. So to the right on the number line. So key thing here to mention, open circle means not included. While as a solid dot means included. I hope that that could be like a thing that you would try to memorize, but I hope it kind of makes sense just by the design, right? If I put a circle around it, it means that it's not there. I've said like, "Oop, you're not there." Whereas if I solid dot it in, it means it's part of it. But that is the terminology. But there is a new way, and I really like people to get to that point, and that's the way I will always write it. But Alex is behind the times on this one. I don't agree with it, and I'll get off my soapbox when we get there, and just, I'll step onto it and then step off in a moment. So, and much like anything in mathematics, there are a million different ways to describe things, and there's a million different ways to write it, depending on what it needs to be in the context. So the most important way for this class is this definition, which is interval notation. Interval notation is a way to describe an inequality. This is a way to describe an inequality in terms of its most basic components, just the numbers. So the number and symbol that is more left on the number line always goes first. So I would say more negative, but it could be, you could have it like it could all be positive. But so the one that is more left on the number line goes first, comma, the bigger number, the number more on the right. And then parentheses and brackets will be used on the outside of these two numbers, depending on what type of inequality. If you have a strict inequality, it's denoted with parentheses. It's denoted with either this and or this. And you'll see why I say and or in just a moment. Whereas if it's a non-strict, we use brackets. So we use bracket, a left bracket or a right bracket. So I've got what we call a compound inequality here. -2 is less than or equal to x, and it's less than 5. So if you want to, you can write this down. But what this means x is greater than or equal to -2 and x is less than 5. So a compound inequality, this is a type of compound inequality. X is sandwiched between these two numbers. So it's larger than -2 because it's on the other side of the mouth. That's the way I was just describing, like an alligator. And then it's less than 5 because it's before the 5. And so the interval notation, the first one is non-strict, and the second one is strict. So it's going to start with a bracket. The number that is more left on the number line is the -2. So be -2, comma, and then the one that's further right on the number line. And then since it's a strict inequality, we write it like that. Parenthesis means that it cannot be included. Bracket means that it can, that it is included. Any questions on that? We're gonna get plenty of like there's the next problem is going to be filling in a lot of these things. But there's an important little factoid to bring up is that infinity and negative infinity are concepts. Something that we frequently forget in mathematics. I ask this of my calculus students because it's an important thing. Infinity and negative infinity, they're not numbers. They're a concept that we use to extrapolate our knowledge and to expand our knowledge of what mathematics is. Because you can never reach infinity, right? As soon as you try and reach infinity, it just becomes one more. And then you try and grab that one, it just keeps going more and more and more and more. So since we cannot actually include it, we have to use parentheses. So if I say x is greater than -10, that's going to be all the numbers that are to the right of -10. And it's a strict inequality. Strict. So the number that is more left on the number line would be -10. Infinity is not a number, but it is farther right on the number line. So it should go parenthesis -10, comma, infinity. You can write a positive infinity if you'd like, but either way. I try to change. I try to make sure I don't do it for class, but like I have a thing where I always write -10 positive infinity. I always write a plus sign because when I was in calculus, I had written my answer as positive infinity, and then I wasn't sure about it, so I erased it, and it turned up it was very very poorly erased, and it looked like a negative infinity, so they marked me down. They gave me the wrong they marked me off for that, and so I said, fine, if you're gonna mark me off for that, I'm gonna always be very very particular about it. So I always write a plus sign, but it's not mandatory. So just like that, and then this one, x is less than or equal to 99. So that's a non-strict inequality because it could equal 99. So it's all the numbers that are to the left of 99, on and on and on and on forever. So it'll be parenthesis, negative infinity to 99, and then a bracket. Oh, use the bracket here. Now, creating interval notation, I'm going to draw something that might help us. When you're first starting out with this stuff, it's very helpful to draw it on a number line at the same time. So if you'd like, and some students, when they're starting out, they write infinity and negative infinity over here just to make it like to remember where it starts. But you don't have to do that. That's just if you struggle with making sure to know where to start and or where to finish, put them on there. And so -10 is right about here. It doesn't need to be perfect. And so it's all the numbers that are greater than it. So it's all the way over here. And then there's an open circle. So if you're reading the number line, the one that's more left is -10. And since this goes on forever, the right hand, the second value, quote unquote value, should be positive infinity. And then we cannot include infinity, so we put a parenthesis. You do the same thing for the 99 one, if it helps. Once again, I'm going to draw this. You don't have to, and I'm going to typically stop doing it unless you guys want me to. But like the left-hand side goes on and on forever until negative infinity, and the right-hand side goes on and on to the right till positive infinity. And let's just put 99 right here. And it's all the numbers that are less than it. So to the left on the number line of 99, but you can include it. So we'll put a solid dot, not an open circle. Any questions on that? On interval notation? Interval notation is probably the most common way to write inequalities. Very, very useful to write things succinctly. That's one of the things we love to do in mathematics, is if we can save ourselves some time and write things succinctly, we try to do that. But either way. So the way to remember which one's which. The way I like to think about it, so which one is the parenthesis, like which one can include and which one can exclude. So if you look at 3 right here. Here is 3. We have x is greater than 3, strictly greater than. So it's going to be to the right of it. Now, this is the new way to write it, and this is the way we should write it as a society, but for whatever reason, we want to stick with the open circle and the solid dot. But just draw a parenthesis. And so zooming in on this, it barely touches x equals 3. So we don't include it because it just lightly touches it and moves on. It can't be included. Whereas with x greater than or equal to 3, if I were to draw this one, all the numbers to the right of it, it goes right through. So it's included because it goes straight through that dash mark, whereas the parenthesis just touches it and moves on. That's the way I memorized it. And so when I'm writing these things down, and you'll see it on the next page, I prefer this new method because it makes it so that you can immediately go from number line to interval form, interval notation, without having to remember that solid dot means included, which means that it's a bracket, and open circle means it's excluded, which means it's a parenthesis. That it's just an extra step that doesn't need to be there. But sadly, Alex does that, but you can write it on any in any format on my exams, and I'm happy with that. So the next one, the next way you can describe inequalities, specifically the set of inequalities, is set builder notation. And so set builder notation is a way to describe an inequality as a set of elements. Set of elements. So this is very, very useful in upper division mathematics. There's a whole field of mathematics called set theory. And so being able to write things as sets is very, very, very useful. Interval notation is writing it as a set. It's just not as constructed as set builder notation. So what set and builder notation would be is a curly brace, and then you write X. I'm not going to write it here because this is the way the textbook does it, and this is the way most people for under like when it's quote unquote clear from the context. But usually people were like in upper division mathematics will write like something like this. And if you remember that notation, that means X is an element of R. X is an element of the real numbers. But that's usually ignored until you get into upper division mathematics. And then you write a vertical bar. And then there's some requirement on X. That's set builder notation. The X is always there, and then the requirement is whatever you need for it. So the way it's read is the set of all X such that the requirement is satisfied. And so I'll explain what everything means. Second, let's write that down. That is set builder notation. It's not that you can either say set notation or set builder notation. Either way is fine. I'm just doing this for the note for the homework. There's a couple problems that do this, but for the most part, we will only work with interval notation. It's just so that we know how to interpret it on our homework. This is something usually for upper division mathematics. It's not something that's really needed, but for whatever reason, we like to include it in this thing. So the curly brace is telling me the set. That's what the curly brace tells me. The curly brace tells me this is a set of all X. That's just the term that's here. If it was a Y there instead, it would be the set of all Y. If it was a Z, it would be the set of all Z, and so on and so forth. Then such that comes from that middle bar. That middle bar is saying, okay, you've got all these element X such that they require that they meet the requirement of X. That's how set builder notation is set up. And so the reason really why we include this, it's a semantics issue in mathematics. Specific, like as a specific example, if I say X is greater than 0, that's a statement. X is a variable, so it's an unknown value. So X could be 5, X could be 17, X could be 3 billion. But if I say curly brace X such that X is equal to greater than 0, I'm saying the collection of all X values that satisfy that inequality. So it's just a semantics argument. It's a way to write down what the actual set is. So that's the main reason for it. And so in short, the trick is the set notation for inequalities, which is the basically only way we're going to see it, is this. The set of all x such that your inequality goes there. That's all it is. So when you see it on your homework, that's what this means. So the set builder notation for the inequality x is greater than negative 30, x is strictly greater than negative 30, is curly brace x such that x is greater than negative 30. That's all it is. It's a really stupid thing. I'm sorry. It's just a semantics thing. It's the next one. All it is saying the set of all x such that negative 6 is less than x, which is less than or equal to 1. And then just so you know it, just because it's kind of cool, fun thing to write, but you don't actually have to write this. You don't have to know this. If there is no solution to an inequality or no solution to an equation, we write this symbol, a 0 or a circle with a line through it. That's called the empty set. Sorry, circle with a line through it like that. That's called the empty set. It's a set that has no elements. Here's just a fun little weird thing in mathematics. Here's a fun thing that's weird in mathematics. This set has no elements. This set has one element. It's a set containing the empty set, which is a really, really weird semantics argument. Like it's a stupid argument, but it's one of those things in mathematics, just really, really trivial and weird that happens in mathematics. If I just write the empty set, that means no elements. But if I say a curly brace around it, it's the set that contains the empty set, which is really, really circular and weird. There's some weird things that happen in mathematics, and that's one of them. Okay. So that's how you use set building notation. I'm never gonna ask you to, like, besides on this guided lecture note portion, I'm never gonna ask you to write things in set building notation. It's just so that you know how to read it for the homework. So the symbol used, if you have a less than symbol or a greater than symbol, the type of inequality, that's a strict inequality. And in interval notation, it's parentheses and slash or that. So strict inequalities, they have the parenthesis because the parenthesis touches but does not include. It just barely taps it. And then on a number line, it's an open circle or a parenthesis. I like using the parentheses, and that's the way I'm going to do it. But just so that you know it for the notes or for the homework, they'll require you to do an open circle. If you're working on the quiz or whatever, and that shows up, you can use your notes, like you can use this section just to remind yourself if you're struggling to memorize that. And then we have the other set of options, which are the other symbols, which are the less than or equal to or the greater than or equal to. Those are non-strict. And for those, we use the brackets. And so that will be a solid dot or a bracket. Just to sum up the notation of which one to use where. All right. They'll write down for a second in case they're still writing down. ...20 minutes. We'll probably get through this. So to work onto this problem, we're just going to fill in all the blanks that are there. So we'll just go in order. So once again, set builder notation is just a really, really circular jump through a hoop situation where we just write it, the curly brace, the set of all x such that x is less than or equal to 2. So on a number line graph, the stupid old way would be to use a solid dot. So it's all the numbers that are less than or equal to 2. So is the arrow going to go to the left or is it going to go to the right? To the left. So it's all, so we'll just plot 2 right here. And then if you're doing the stupid old way, it'll be a solid dot and then like that. Whereas if you're doing the super cool new way, it'll be a bracket like that. And yes, I was that petty. I was deciding whether or not I would just write it on the first one or not, but I was so angry at it at 10 o'clock at night that I decided to include it every single time.
What do you like better?
I like the super cool new way. I like that way because it just makes it so that interval, like, so what you'll notice is that if you write it this way, interval notation is immediate. That's the cool thing. So remember, this is, I'm going to write this time. This is negative infinity. This is positive infinity. I'm typically going to not write that though. So where does our interval start? Negative infinity. It starts at the very, very end, forever on. So, and since we can never include the infinities, we do a parenthesis, negative infinity, and then it stops at 2, but it can include it, so it's a 2 bracket. Do you notice that this thing is exactly there? Boom. It's immediate. That's why I like the new way. That is the way we should do it. There's no reason to do the solid dot in the open circle. The only argument I could think of is to talk about open circles in 2 dimensions, which we'll get to soon enough, but it's a dumb argument. So set builder notation for the second row. We're only given the set builder notation. It says the set of all x such that x is greater than -5. So the inequality is x is greater than -5. So the stupid old way, here's, we can plot it wherever we want. It really does not need to be perfect. Here's -5. So if we're going to do a strict inequality, it cannot be included, which means it's going to be an open circle. And the question is, do I go to the right or go to the left? To the right, because it's all the numbers that are larger than it, which would be the numbers that are more right on the number line, more to the right direction. Or the cool new way, bracket, or sorry, parenthesis, on and on forever. And so once again, if you're using the super cool new way, then you don't need to do anything. You just transcribe it. It starts with a parenthesis because you can't include it, -5, comma, and it goes all the way on and on forever. So it goes into positive infinity, and we cannot include it, so we do a parenthesis. Any questions so far? The next one is a compound inequality. It's x is greater than -1, but it's also less than 7. But set builder notation is curly brace, all x such that -1 is less than or equal to x is less than 7. So there's 2 values that x is sandwiched between. So we'll plot both of those values on the number line. So -1, and here's 7. Here's -1, here's 7 for the new way. So, and let's use purple. We haven't used. So if we're doing the stupid old way, is -1 going to be a solid dot in our open circle? Solid dot, because it's included. And then an open circle at 7 because it's not included. It's a strict inequality. But if you're doing the cool way, it'll be a bracket and then a parenthesis at 7. And so if you use the cool way, it's immediate. bracket -1, comma 7 parenthesis. And you have my permission. If your teacher in the future uses a solid dot in the open circle, you can say that Phil said you're an idiot. Not an idiot, just behind the times. All right. The next one. We're not given the inequality. We're not given the set builder notation. We're not given the number line, but we are given the interval notation. -infinity to positive infinity. So that's every number. So to draw it on a number line, that would be arrow all the way on and on and on forever. This is the only time where the cool way and the old way are the same. So to write this in as an inequality, you would either say that x is sandwiched between -infinity and positive infinity, or you'd say all real numbers, which could be denoted with that bold case R if you want to. It's an interesting situation. And so the set builder notation would be the set of all x such that -infinity is less than x is less than positive infinity, or you could say all real numbers, which would be all real numbers, which is equal to that boldface R if you really want to. All right. Any questions so far? So what's the inequality for the next one? X is less than -1. That's right. X is strictly less than -1. So the set builder notation would be the set of all x such that x is less than -1. And then to the interval notation, then it starts all the way to the left forever on. So it'll be -infinity, which we cannot include. So I'll put a parenthesis, -infinity, all the way up to -1, but we cannot include it. So we use a parenthesis. Please, on the exam, if like, because I guarantee you there's going to be some place where you're going to have to use interval notation. You're going to have to write it. Don't try and pull the true false trick. Don't go like this. Like, if you try and do that, I'll be very cross with you. Don't pull it on me. All right. Next one, we're given the interval. Set of all x between -8, including -8, and positive infinity. So what's the inequality? Mark says x is greater than or equal to -8. And he's right. X is greater than or equal to -8. So that's the set builder notation is the set of all x such that x is greater than or equal to -8. And so we'll just plot -8 right here. Doesn't matter where you plot it. You could put it right in the middle. We're not worrying about scale. It's just it's a way to visualize it. It's all the numbers that are larger than it. So we're going to go to the right. So let's use have we used blue? No. Let's use brown. Solid dot because it can be included all the way on and on and on forever, or a bracket and then on and on and on forever. We come to our first interesting strange case. X is less than 0, or X could be greater than or equal to 9. That is that is an or statement. So that means it could be one or the other. As long as one of them is true, the inequality is satisfied. So if you're -1, you're in that inequality. You're in that set. If you're 500, you're in that set because you're greater than 9. But if you're 5, you're not in the set because you're neither less than 0 nor are you greater than 9. Does that make sense? So once again, negative 100. Negative 100 isn't, don't write this down, but negative 100 is in there because negative 100 is less than 0. Positive 100 is in there because positive 100 is greater than 9. But 2 is not in there because 2 is not less than 0 and it's not greater than 9. Greater than or equal to 9, that is. So in interval notation, you would write it in set builder, it would just be the set of x such that x is less than 0 or x is greater than or equal to 9. And how you draw it. So we've got a strict inequality and a non-strict inequality. So let's plot 0 and 9 on our grid. So 0 and 9. So the first inequality is saying x is less than 0. So it means to the left of 0. So we'll do an open circle because it's strict. And then we'll go on forever. And then x is greater than or equal to 9. That would be a solid dot because it's a strict inequality. And then on to the right forever. In the super cool notation, that'll be a parenthesis at 0 and going on and on to the left, and a bracket at 9 and going on and on to the right. Any questions on that? Okay. I'm realizing, like, based on the time, we're at 10:40. We got 10 minutes. We'll be able to finish this and probably get started with solving linear equations, but we won't be able to finish it. So I'll probably extend the due date of both the quiz and the homework for 1.0.7 until next Wednesday. But 1.1 is still due this week. The quiz is not due this week. I'll update the website, our course homepage as well. But how you write that in interval notation, because that's not one ray or one little segment. So this is where we get to introduce a new type of notation. So what's the first interval? The one, what's this one here? What does it start with? Parenthesis, negative infinity to 0, end parenthesis, because it can't be included. And then we use this symbol, a giant U without the tail. And then we'll include 9. So we'll do a bracket 9 to positive infinity. Parenthesis. This is called the union symbol. If you want to conjoin two things, if you want to combine the two things that they might have overlap, they might not, but that's how you write it. You write a U here. And I mean, some teachers and some students use just a giant U, and that's okay if you don't want to. But the convention is it's just a big like horseshoe shape. All right. Any questions on that union symbol? And if you forget what that symbol's supposed to look like on an exam or quiz or anything like that, just let me know, and I'm happy to provide that. That's something that you don't need to, like, as long as you remember that it's supposed to be a combination of the two. If you forget what you're supposed to write in the middle, just ask, and I'm happy to give it to you. Next one is a deliberate situation. So it's the set of all x such that negative 13 is greater than x. So the inequality could be written as negative 13 is greater than x. But we like to see our x's first, don't we? We like to see our x's first. So you can rewrite it. You can flip it, or by flipping it, you can write it as x needs to be less than negative 13. The inequality has to stay, the point needs to stay with the thing that it's pointing to originally. So since the point ends at the x, it needs to be touching the x. The way I always thought of it is, do you guys remember transparencies? Did your teachers ever use those? Like that old school like sounds like a jet airplane and it just shoots light up on like clear paper. You guys remember that? Transparencies? No? Well, it's a little bit before your time, I would imagine. But like you just flip it over. You just like take the piece of paper that you've written on and flop it over, and you've got the inequality. So that's a key trick that you can do. Just make sure that the point stays with where touches what it was touching originally. So since the point was touching the x, it stays touching the x. So it looks better in that format. So with the stupid old way, that's all the numbers that are less than negative 13. So I'll plot 13 on the number line, negative 13. And so it's going to be an open circle. And it's all the numbers less than negative 13. When we read it the correct way, the more comfortable way, x is less than negative 13. So it'll be all the numbers to the left. So that's going to be a parenthesis in the new way. So the interval notation would be parenthesis negative infinity to negative 13, end parenthesis, because it cannot be included. The next one is a conjunction of the two things. It's two rays that need to be connected together. They need to be unioned. So I'm going to write the interval notation. What should the interval notation be? Not the inequality, but the interval notation. Parentheses, negative infinity, up to including 4 or not including 4? Including, and then we do a union symbol, and then we go to our next largest point, which would be 99 on to infinity. And so I think it was Wesley was saying the or is the correct choice. So it's going to be either x is less than or equal to 4, or x is greater than or equal to 99. That would be the set builder notation, the set of all x such that x is less than or equal to 4, or x is greater than or equal to 99. Questions on that? Last one. It's another sandwich situation, but it's written in the weird way. So all we need to do, and so this is where having an iPad is fun with this. That's all you need to do. Just flip the whole thing around. Keep the points where they belong. So I'm going to flop it. So it should be negative 71 is less than x is less than or equal to negative 4. That's how we would write it if we want to write it in the way that we usually like to see things. We like to see it in ascending order, from most negative to most positive, from furthest left to farthest right. So the set builder notation, you could write it in either format. I'm going to write it in the bottom format because that looks prettier. Negative 71 is less than, x is less than or equal to negative 4. And so that's going to be a little line segment. So we'll plot negative 71 and negative 4. I will accept either format. By the way, the stupid old way or the super cool new way on an exam. You can write it in any format if I do require you to draw it on a number line, but typically don't. And so that's going to be open circle at 71 or a parenthesis at 71. And do I go to the right or do I go to the left? To the right, all the way up until 4 and including 4, because the negative 4 portion is a non-strict. So it'll be parenthesis and then a bracket. So that'll be parenthesis negative 71, comma, negative 4 bracket. Any questions on that? we're probably not gonna get, I want to do one thing here because I want to get us the intuition for this last statement so we can ponder it a little bit more. But so a solution to a linear inequality is very, very similar to the solution of an equation. It's just a number that when substituted in, it creates a true statement. So like if you plug in and you into an inequality and you get like -1 is less than 5, that's a true statement. Or 9 is greater than or equal to 3, that's a true statement. Or 0 is less than or equal to 0, that's also a true statement. In fact, that's a good one to write down. Or 0 is less than or equal to 0. That's a true statement. Because 0 is equal to 0, so it's of course less than or equal to 0. And the way we solve linear inequalities is just like we did linear equations, right? Where we get all the numbers to one side, the x's to the other, except for one thing. Does anyone know what it is? It has to do with negative numbers. If we multiply or divide both sides by a negative number, we flip the direction of the inequality. So if you multiply by -5 and it was a less than, it now becomes a greater than. If you divide by -2 and it was a greater than, now greater than or equal to, now it becomes a less than or equal to. It flops the direction. And I remember wondering why? Why would that happen? And the reason for it is essentially if you multiply everything by a negative number, both sides of it, what you've done to each side, each quote unquote number, is you've swapped it on the number line. You've like slapped it to the other side, to the negative side of things, to the upside down, essentially. So for example, let's say you have x here and 10 here. This is saying that x is less than 10, right? So this is the hopefully this will make you visualize it a little bit better. If I multiply both sides if I multiply by -1, what's going to happen? This -10 is now going to go over here. And this x will now go to right here. And so now, if you were to write that thing, how would you write the relation between the order between -10 and -x? Looking at it, I would say that -10 is less than -x. Or to write it better, that's -x is greater than, and I'll write that in blue, greater than -10. The direction changed. It was originally x is less than, now it's -x is greater than. Because everything kind of swapped. It just immediately, like we did -1, but the same concept is true with like -2 or dividing it in half. It just, that number that was larger, that was further on the right, is now further on the left. And the number that was further left on the number line is now further right. Sorry. The number that's further right is now further left. And the number that was less right is now less left. Does that make sense? That's the reason why if you multiply by -1 or divide by -1 or multiply by -10 or divide by -10, it changes the direction. That's the only difference. So we'll pick up next time with that. Homework for unit 0.7 will be extended until Wednesday of next week. Or homework can't be, there's no way to make it get extended to halfway through a due date. So the 0.7 homework will be moved till next Sunday, but I'd like you to get it done before then. But we'll pick up next time with this. Quiz will be extended until Wednesday since we don't have, there'll be questions like this on there. So if you guys have any questions, feel free to email me. Otherwise, you guys have a great rest of your weekend. And remember that social media turned politics from a form of government into a form of entertainment. And And that's a problem. That's a problem. Politics is supposed to be a form of government instead of tribalism and entertainment. The things that get the most views are the things that get attention. That's not okay. Think about it. Think about it. Have a great day, guys.